Hi everyone, and today we are going to explore Arduino R4 or revision 4, what you can do with it and how. So first of all, and by the way, we are not going to cover code. I'm going to cover code in a later video, but not yet. So this is the Arduino R4 Wi-Fi. You can also get the Minima, but in this case I'm using Wi-Fi. So as you understand, there may be duplicates, but this one is a real one from Arduino because this was newly released, and unfortunately there's no more clones. So as you can see, these ones you can plug in these. These are called jumper wires. They can be used for, there are two types, male to male and male to female. Male to male can plug into one area, but in male to female there's one hole for female, and male is over here. It has a plug. So you can plug it in and connect it to any of these components. There's a reset button and 5 volts and 3 volts to give power. Win is for giving power by a battery. You can use 5 volts, and ground is like where you start everything. They have 3 of these all over the board. Also, because of new updates, it has SCL and STA. They are specialized, and if you see them, just plug them right in. This is an expressive ESP32 unit with a PCB antenna, which basically means it has Wi-Fi. And this is at mega chip. Combine these two and you get a Wi-Fi, and also you get 5 volts, because normally ESP32 is 3.3 volts. This is 5 volt ESP32 you can still use. This is an LED matrix. It is 12 by 8, and once you install the board package, because you need to install a board package because it's not on normal Arduino boards, it gets automatically installed with it. This is I2SP, which you can use for any device that uses a form of communication. I got this one for about 20 quid, and overall when I checked it, I think it's sort of nice with a DC jack, and it can also handle 9 to 24 volts because of USB, and of course a reset button. So today I'm going to show you how to connect some components with it and how. So first let's start with this basic one, the sound sensor. So first you may see that there's a simple DO at the last one. You don't need to connect it. That's for simple clap recognition. A0 stands for analog output, and you can put it into A2. Unfortunately today I can't show you the code, but for few of them which are responding, I think I'll be able to show you its output. And also here is ground, normally described as G here, where you can just plug it in and just plug it into G. And the last one, plus. Plus is just for 5 volts. So you can just plug it into 5 volts, only 5 volts. Some of them you can't plug into 5 volts, but if we can't, I will surely mention that. So yeah, done. As you understand, it's as easy as cutting a cake in half. So pretty easy. But if you want to code, there are some cool browsers called ChatGPT, Atlas, Google AI that I normally use for some of my projects. Also, here's a potentiometer. I can increase its resistance by this amount, by a certain amount. If I turn this clockwise, it makes it more sensitive, and if it turns anti-clockwise, it makes it less sensitive. Once we plug it in, I will be able to show you a small clip of me plugging the devices in, and after you will be able to see how. Okay, so let me just unplug all of this. Now we are going to have a HR SO4 module which can use ultrasonic It can use ultrasonic to detect if something is close and is distance. This one is only accurate per 3 millimeters, and if you want, and can only detect up to 400 meters. If you want something more accurate, I suggest you start looking into LiDARs. So first, VCC just stands for power. So you can just put it in 5 volts. You can also put this in 3.3 if you would like to, but I don't suggest it. Trigger can go into any of these digital I/O pins. PMW means pulse width modulation. So I can put it on number 7 here. I'll put this one on number 7, and this is the echo. Normally it says instructions, and currently this says I have to go SDA. SDA, by the way, is pin number 20, and finally ground, because this is where we end our circuits and it comes back to loop all over again. And done. If you like, you can attach a servo motor here so that it can spin, and using a processing IDE, which is an IDE which is specialized for showing graphics smoothly, you may be able to produce a radar-like image. Now I'll show you a touch sensor. This one you only need 4 pins, but trust me, soon you need a breadboard, which is this thing. I suggest 830 pins, and this is attached by a covering and rails here, as you can see, and this one is corrected horizontally, not all the way. As you can see, there's a ginormous gap here. You can see plus and minus signs and ABC and numbers there. That will be useful if you help. For my next thing, I'm going to show you after this touch sensor. This touch sensor, you can use this SIG. Just plug it into any digital pin. Please correct me in the comments if I'm wrong. Ground can be used for here, and after that VCC is 5 volts, as VCC is power. So that's it. By the way, it will be kind of cool if you can create activation, because it detects heat from your body. So finally, here's a humidity and temperature sensor which you can use for your projects. For this one, I'm going to use a different type of sensor. I'm going to use a different type of jumper wire, which is male to male today. So first step is you have to turn it over, or else the other side isn't that smooth, and plug it into one of these holes. Plug it like this because these ones are connected horizontally, as you know, and these ones are connected vertically. So also, if you want to match 2 components together, you have to wire it, and if they both use this 5 volts, you have to wire them in series so that they use the same amount of power. Series is convenient because there are 2 types of circuit, parallel and series. Series has no disadvantages, but parallel, if one part of the circuit doesn't have power, the entire circuit fails. That's why I normally use parallel, because it's much more convenient for my. That's why I use a series, because it's much more convenient and easier to assemble. I'll show you how to assemble one in my future video. So after you plug this all in, I'll show you how to plug it into the R4. So first step for the R4, the VCC. I'm so sorry guys if I have to unplug it. So so far this orange pin will have to go to 5 volts. I usually like to measure by counting how far along is it. This one currently SDA goes to SDA pin number 20. We call this GPIOs, general input output pins. This is analog and this is power pins. Analog can measure items like sound. That's why I added one for my previous one. This one is ground, so as usual, plug it into ground. And last one is SCL, pin number 21. If you want, you can use these pins, but I would suggest not. only if you have something that is not compatible with your current 5-volt logic. So all you have to do is plug it in after to a breadboard, and friction should hold it together. Maybe on my other videos I'll show you a preview of what happens. So thanks for listening everyone. Hope you enjoy, and please like and subscribe to my channel. I will also show you some things which I'm not going to do today, but I will do on my next videos. So first we have a screen with buttons. I will be doing this next video, and also we have a joystick module which you can use it's like a joystick. You can calculate its coordinates using the screen I just mentioned. I'll put it in later. And this is what I like to call the master of them all. This is RFDI, which stands for radio frequency identification. You can put a fob or normally code, or this is how debits and credit cards work, and it sends a small electrical pulse for a nanosecond, and it can cause it to read it like really quickly. And no, you can use this to change, read passwords, and even change it using buttons. So technically a portable password changer. So guys, please like and subscribe, and please subscribe for my upcoming video.